Hi everyone, so we're going to go through how to find the electronic configuration of an atom. When finding the electronic configuration of an atom, it's important to keep in mind the Aufbau principle, which states that when building the electronic configuration of an atom in its ground state, the electrons occupy the lowest available sublevel, the lowest available energy levels. So it's important to know the order that they will go in. So it will be 1s, 2s, 2p, 3s, 3p, 4s, 3d, and 4p. So the 4s sublevel comes before the 3d sublevel as it is lower in energy, and so following the Aufbau principle, lower energy one will come first. It's also important to take note of how many electrons can go into any of the sublevels. So the s sublevel has one orbital, so it can hold a maximum of 2 electrons. The p sublevel has 3 orbitals, so it can hold a maximum of 6 electrons. And the d sublevel has 5 orbitals, so it can hold a maximum of 10 electrons, as each orbital is only able to hold 2 electrons each. So let's take carbon for example. Carbon as an element has 6 electrons in it. So we will always start with the 1s sublevel. So we can take a maximum of 2 electrons. So since we have more than 2, that one will be fully filled. We then move to the 2s sublevel. So we still have 4 electrons left. So the 2s sublevel, which can hold 2 electrons, is also fully filled. We then move to the 2p sublevel. So we've used up 4 electrons so far. We have 6 in total, so the remaining 2 will go into the 2p sublevel. And these small numbers up here should add up to give you the 6 electrons that you started with. Say if we take fluorine for example, fluorine has 9 electrons, so starting again from the 1s sublevel, so 1s2, 2s2, and then the remaining 5 will go into the 2p sublevel. We take something from the n is equal to 3. Let's have a look here at phosphorus, which has 15 electrons in it. So we'll have 1s2, 2s2, 2p6, 3s2, and we have 3 electrons left, so that will go into the 3p sublevel. A quick and easy way to figure out where it is going to end up is, if I try to draw just a very basic sketch of your periodic table, we will only ever have to deal with up to the 4p sublevel. We don't have to worry ourselves with the s. So if you kind of compare this here to the way that your own periodic table would look, this here is your s block, this is d, and this here is p. So there will be 10 electrons across the way, so 10 elements across the way here, 2 elements across the way here, and 6 elements across the way here. So for example, let's have a look here. And so, one other thing, each individual row is given a number. So it goes down to 7, but we won't go past 4. So say let's take magnesium for example. Magnesium is in the 3rd row, it is in the s block, and it is the 2nd element in that s block. So this is going to be the final orbital in magnesium's electronic configuration. Following the Aufbau principle, everything else before that will need to be fully filled. So we know straight away that we're going to have 1s2, 2s2, 2p6, and then we're going to finish with 3s2. Using that same thing, we can have a look here at, let's have a look at germanium. So germanium is in the 4th row, it is in the p block, and it is 2 over in the p block. So germanium is going to finish at 4p2. So this is going to give us 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and then 4p2. So we don't even have to try to figure out all the rest of it once we know where it finishes. And we can use that same rule to figure out what the element is based on its electronic configuration. So say if we have 1s2, 2s2, 2p6, 3s2, 3p2. So we know this is where it finishes. So it's in the third row, it's in the P block, and it's 2 into that one. So that means it has to be silicon. Another way you can do it is if you add up all the small numbers here, that will give you a total of 14 electrons. So if you look for element 14, again, that will give you silicon. Both ways are perfectly acceptable to find the element based on its electronic configuration, if that's what they're asking you to do in your question.